Number 1, how many tons of titanium oxide can be extracted? The easiest way to do this is actually to compare the ratio of their MR. For example, we can have the MR of the titanium oxide over the MR of the ore that is to be extracted from. So we have 80 over 152, and then we multiply by the total mass of the ore. So this is the portion that's made of titanium oxide. In the end, we have 10 tons. Number 2, we burn carbon disulfide and then we treat the gases with aqueous sodium hydroxide. The purpose of sodium hydroxide will be to absorb whatever carbon dioxide was produced. Carbon dioxide is acidic, sodium hydroxide is alkali, so it will remove carbon dioxide at the end. So easiest way to do it, again, we will use a table and compare the volumes before and after. We start off with 10 carbon disulfide and we have 50 cubic centimeter of oxygen. No carbon dioxide and sulfur dioxide at the start. And then we look at the ratio. We can see that carbon disulfide is limiting. So all of carbon disulfide will be used up, minus 10. It will at the same time use up 30 cubic centimeters of oxygen because of the ratio. And when minus 10 or 10 cubic centimeter of CS2 is used, the same amount of carbon dioxide is produced and twice the amount of sulfur dioxide is produced. So we do a tally. We have no CS2 at the end. It's to be expected because it's limiting. 20 oxygen, 10 carbon dioxide, and 20 sulfur dioxide. So the first measurement, we will get 50 of gases. Okay. And then I mentioned the sodium hydroxide will absorb carbon dioxide. Okay, I did not mention that actually sulfur dioxide will also be absorbed because it is also acidic. So we have 50 in total. When 30 is absorbed, we only have the 20 cubic centimeter of oxygen left. 50, 20. Question 3. Which one only has one electron in the s orbital? I've written out the s orbitals for the atoms, which you can compare to what you wrote out. Okay, things to take note of is the copper. You have to remember that it is 3d10 for s2, not 3d9 for 3d10 for s1, not 3d9 for s2. Okay, and then when we reach chromium, 3d5 for s1. Lithium 2s1. So for chromium and lithium, there has only one electron in the s orbital. Number 4. How many electrons are there in hydrogen carbonate ion? Hydrogen carbonate is HCO3 minus. First of all, we figure out the protons. 1 from hydrogen, 6 from carbon, and 8 multiplied by 3 for oxygen. So we have 31 protons. But because it's a negative charge, it will have one extra electron than proton. It will have 32 electrons. Number 5. Which one will compare the relative strengths of the hydrogen bond between the molecules? So the stronger the hydrogen bond, the stronger will be the intermolecular attraction, and it will affect the energy required to vaporize them, change them from a solid or to a liquid to a gas. So hydrogen bonds affect the heat of vaporization. Number 6. Which substance is combustible, electrical insulator, and melts over a range? It means it's a mixture. So we have polyethylene that shows all these properties. Brass is a mixture, but it is a conductor, so it's out. Paper, we don't melt, it doesn't reach melting point, it actually combusts, right, when the temperature gets high enough. Silicon dioxide is a non-conductor and doesn't melt over a range also, right? It's a compound, have a fixed melting point. Number 7, which one behave most like an ideal gas? Means lowest intermolecular attraction. If you go down the 4 options, all of them are non-polar, so all of them are induced dipole-induced dipole. Since all of them have induced dipole, we can compare the MR. The lower the MR, the lower the intermolecular attraction. So helium has the lowest MR. If you have the lowest intermolecular attraction, you will follow ideal gas laws most closely, because that's one main assumption of ideal gas. Number 8, what values are required to calculate the enthalpy change for this reaction? The common ones to calculate enthalpy change of reaction is we have combustion information, we take reactants minus products, or we have formation information, we take formation of products minus formation of reactants. So looking at the 4 options, only option D gives us sufficient information. We have formation of the reactants and formation of your products. So that will be sufficient to calculate heat of reaction. Number 9, we have a reaction pathway. What can be made about the reverse reaction? This is the enthalpy or the activation energy of the forward reaction. The one on the right is the enthalpy or activation energy for the backward reaction. We can see that the backward reaction has a larger activation energy. The backward reaction is also endothermic, okay, because your starting point is lower than your ending point. Number 10, which one will change the Kp? This is based on the understanding that Kp, Kc are affected by changes in temperature. So D will be the answer. Adding catalyst will not shift the equilibrium, or will not change the Kp also. Increasing pressure, adding the concentration of or reducing the concentration of products, reactants, will only shift the equilibrium, but not change the Kp and Kc. So temperature is the one that will change the Kc or Kp. Number 11, we have this nitrogen tetraoxide becoming nitrogen dioxide, and we are given the equilibrium pressures. So the Kp expression will be pressure of NO2, but we have to square it because there's a 2 down here, so we square, and over pressure of NO, partial pressure of N2O4 is 1, so we power 1, and we substitute in the equilibrium pressure, we will have our Kp. Number 12, we have a reaction that is catalyzed by aqueous palladium ions. So which statement is not correct? A, changing the concentration of the catalyst will have an effect. The catalyst is an aqueous form, so it will have an effect on the rate of reaction. Pd2 plus equals increases the energy. This one is incorrect because the catalyst will decrease the activation energy. it doesn't change the energy of the reacting molecules. The reacting molecules energy will be changed if we increase the temperature. So B is not correct. Statement C, like I was mentioning, it lowers the activation energy. That's what a catalyst does in this case. And how it does that, it actually allows the reaction to proceed by a different route. 13. Which oxide when mixed with water is the most acidic? Carbon monoxide is neutral. Carbon dioxide slightly acidic. Silicon dioxide is not soluble, so the pH will still be 7, neutral. And P2O5 will give us H3PO4. So it's an acid. So it will be the most acidic solution. How can we get which salt is produced by adding aqueous ammonia to aqueous sulfur dioxide? Aqueous sulfur dioxide in water, there's an equilibrium setup, we get H2SO3, which is acidic. And when we have ammonia, they will react to form ammonium sulfide. Okay, SO2, SO3, 2 minus being the charge, NH4 plus for ammonia. So we have the salt C. Ammonium chloride catalyzed reactions using under this equation. You can see that it actually takes in one extra Cl minus to form AlCl4. How that happens? Okay, you can visualize AlCl3 at the bottom. The aluminium has only 3 outer electrons, so there's only 6 electrons surrounding aluminium at this point. It has an incomplete octet. Here we have the chloride ion. It can actually donate 2 electrons. It donates a lone pair to fulfill the octet structure for aluminium. So the aluminium atom in AlCl3 has an incomplete octet that allows it to take in or to form a bond with the Cl minus. Number 16. Due to the similar ionic radii, lithium and magnesium are very similar in their reactions. Which one is correct? Lithium carbonate decomposes to form lithium oxide and carbon dioxide. Okay. We know that magnesium carbonate, when decomposed, forms magnesium oxide and carbon dioxide. So if lithium is similar, we expect lithium carbonate to behave in the same way. What is wrong with B? Lithium nitrate decomposes to form lithium nitride and oxygen. Magnesium will form magnesium oxide, nitrogen dioxide and oxygen. So lithium should follow that same pattern. Magnesium burns very vigorously in oxygen with a bright flame, so we expect lithium to do that also. Okay. Magnesium reacts slowly with water, so D doesn't fulfill the condition.